Play slideshow. There we go. All right. Now I know what I'm talking about here. All right, so just a quick start. What is reverberation? I don't know if any of you need to have that answered, but it's like, I would say like Wikipedia talks about as like the persistence of sound after a sound is produced, which I think is good, because it's like the idea is like it doesn't say it's echoes, it doesn't say it's like the whole bunch of reflections in a room. It's just based on what we hear, which is that you don't say why it's persisting, but it persists. And I also like this reverb developer from the 70s and 80s, Christopher Moore, came up with this phrase spectral plasma, and I really like that. It's a good way of kind of showing that like the reverberation has all the sounds that you put into it, but it just sort of jumbles them up. It takes out any sort of temporal coherence and just gives you sort of a smear of sound. And that's like, I get into that, like I think that like reverbs and echoes extend a sound and sign, but they're perceived differently. For example, I could just show you, I'm sure you all understand, but like this is an echo. Like, you hear discrete repeats in there. Whereas a reverb, it's going to be much more like there's no real discrete echoes. And there can be in reverb, but that's not what most people are used to with that. All right. And now I don't remember how I just got to that slideshow. Sorry about this.
Play.
Play. Thank you so much. So a reverb can consist of thousands of echoes, like spaced closely enough together so you don't really hear any gaps in the signal, but also can just be randomizing the sign phases of the individual components in the signal. Like a really good smeary reverb is take a giant FFT of a signal and then randomize the phases. It sounds really reverberant. So even though there's no echoes in it at all. So one of the terms I use, RT60, it's what use standard measurement of reverb time. Time it takes for the signal to decay to 1/1000th of the original strength. And they often do it in different frequency bands. So it's like, but like usually when they measure like the RT60 is like in the mid-range or something like that. So early reverbs, one of the things that you had in like churches and cathedrals, that's probably one of the first structures where the reverb was not only sort of designed in, but was a major function, like major kind of like factor in what was done in those spaces, because they had massive reverb times, 6 to 9 seconds common, sometimes exceeding 12 seconds. Just to give you an idea of what that sounds like, let's just bring this up and let's put in like a 6, or let's put in a 9-second reverb with a short decay. That lasts a long time. And some of the huge cathedrals, it really is like, gets longer than that. So, and if you think about it, priests like couldn't really talk in a space like that, because if you heard someone talking, one, it's a giant space, it's hard to be heard, and everything smears together. So like all the, all the speech just turns into this big wash. So the idea of Gregorian chant, it might have been a way to communicate ideas like in an area where you really can't hear the individual phonemes or anything of speech. And then the other thing is that fast musical passages, like if you're doing something, it's just a blur. So if you're doing like a, like you can hear that, but it's like I saw Van Halen in the Kingdom in 1988 and he was doing his little eruption solo and it just sounded like ambient music. It was really beautiful in that way. So, but like that's the idea. It's like monophonic phrases can turn into polyphony just because they hang out in that space. So music in a cathedral needed to be slow and really deliberate and kind of designed about the fact it's like, just be used for like your last several notes are going to be hanging around there for quite some time. Chamber music is like in big rooms, but not as big as concert halls. And I don't know the names for those sort of rooms because I don't really know classical music that well. And it's like, it's a shorter reverb range, like 1 to 1.4 seconds. And it kind of increases the spatial perception, increases sort of the richness of it, but it doesn't blur things together. So something like that would be, let's turn the attack down. So it's like, So, you know, you could see where you can actually have more complicated passages in that, and you'd be able to hear like all the notes. Concert halls were designed to like have a lot more people in them, and then also a lot bigger orchestras, and so symphonic works sort of evolved with that. Like they have a longer reverb time. And it turns out that when people talk about the best concert halls, like they talk about Boston Symphony Hall, or they talk about the one in Vienna, they usually have an mid-range RT60 between 1.9 and 2.0 seconds. And the longer, but there's lower frequencies, you have a much longer reverb time than that. And that gives you a higher perception of spaciousness and envelopment, which I don't think we're going to be able to hear in these speakers tonight, but you can just get a little bit of the idea of what a reverb like that sounds like. And in this case, it's already kind of set up to do something like that. Which sounds short compared to the Cathedral, but it's still a fairly long reverb for what you'd have, like, you know, for like orchestral music. So this is where I get into more of my strengths. I'm not a classical guy, but I know more about artificial reverberation. And so one of the first artificial reverbs came from the ideas, I mean, this actually goes back a couple of thousand years in some ways. They had echo chambers in some Greek theaters, or like they had kind of like jars that would resonate this. Like, but in the world of electricity, it's a simple idea. You take part of your signal, you send it to a speaker. That speaker's in a room. It's a dedicated room for that. You put a microphone somewhere else, you record what's coming out of the microphone, you mix some of that with the original signal. And then there's ways of, like, you know, you probably want the speaker aimed away from your microphone. Like the microphone might be aimed there, speaker aimed there. You shut the doors. It's really nice if you have like, they worked well in bathrooms. Like the first ones, like there was a, who was it? Bill Putnam Sr. just recorded something for the Harmonicats, and he used a bathroom echo chamber. And then concrete stairwells were really popular for this stuff. Like Columbia Records, they had a 7-story stairwell, speaker on the top, then a microphone on each level, and that's like a lot of amazing records were recorded with that reverb. Now, and like the same thing like at Abbey Road, like you had like a storage room that was repurposed to be a reverb chamber. The problem is, it's like, you know, with those repurposed rooms, there's isolation. If it's a bathroom, you can't have anyone using the bathroom or running water or anything like that. That was something, you know, so you had to kind of like take that room out of commission, at least during the recording. So they ended up designing reverb chambers, and they designed them for optimal sound. Like they tend to have non-parallel walls, kind of like a wedge like this, where you'd have like the short part of the wedge. Let's see if I have a picture. You have the speakers, and then you have the microphone aimed away from that. And like you wanted hard reflective surfaces. Concrete is good. They often do like multiple layers of drywall covered with plaster. And the characteristics had really high early echo density. Echo density is like, some people talk about the grain of a reverb, and how I tend to perceive that is kind of like what the initial attack sounds like. Do you hear any sort of, like, is it just a little of sound, or is it kind of a like that before it builds up? And in a chamber, it's like any other physical room, the echo density builds with the square of time. So it, like, if you have a certain density, just give it a little bit and it's going to build up. And also builds by the square of frequency. Again, that's true of any like 3D physical space. And then the RT60, like the reverb time above 2 kilohertz, it starts to fall really quick because of the air absorbency of air. So it's like at 10 kilohertz, you can't have a reverb time higher than 1.25 seconds or so. And you can have really long RT60s at low frequencies. And that's not really that big a feature. Like, you know, if I do an example here, like let's turn off all the high frequency damping. It's like you can hear like let's put in like a long sound. Like that's something that's a very digital sound. We're used to nowadays we're used to digital reverb sounding like that. In the olden days, though, it really, you had so much high frequency absorbency that you would never have like Like a long reverb would always sound darker like that. And that makes a big difference when you have speech going through it, or like singing, because it's like, you know, every time has like, is it sibilance, sibilance, thank you. Those sounds in a digital reverb will just like can be like go on for a long time. It's a really 80s sound. And that's part of it. It's like that was part of the sound of the 80s, like these reverbs acting in ways that physical rooms just can't act. Whereas in reality, it's like any physical room is almost like a natural de-esser. The bigger it is, the less you're going to hear those, like any sort of consonants ringing back. And even if they do ring back, it's only going to be for about a second to a second and a half at the most. So that makes it kind of like, you know, like chambers are really good for like more like, you know, acoustic music, singing, kind of like stuff where you want to have this like, I don't know, they talk about warmth and realism and all that, if that's something you're looking for. Drawbacks of it, it's a lot of room to have an echo chamber. And like, you know, it's like one of those things, it's not just like it's not just that you have to have a speaker in there and a nice microphone. You have to have the space. You can't buy one, you have to have it designed, but you have to have the actual physical space in it. It has to be built. It's not the sort of thing you want to build in a rental. It has to be like, there's skills. You have to have people that know how to apply plaster well and all that. And you can't really adjust the reverb size unless you have like some movable wall in it, or like a ceiling that lowers up and down. And there is a reverb chamber in Blackbird Studios in Nashville that does that. So that, I mean, it's a beautiful sound, but it's expensive and you can't adjust it much. So in the 50s, EMT Electromesstechnik released the EMT 140 plate reverberator, and that was really a big innovation. All it is like, it's a sheet of thin rolled metal, and it's about like maybe this big across by about this high, and they're in a plywood box. It's the size of a twin mattress. It weighs like 400 pounds, and it's got a driver on the, like it's suspended in the steel frame. It's got a driver to put the sound in one place and a couple of like some sort of pickups that kind of pick up on the bending waves, and it sounds really beautiful. There's a picture of one, but they don't look like that when you see them in real life. When you see them in real life, they look like a plywood box. They're very not photogenic. And then they have, like, you can't see it here, but they have a damping like plate that comes, the closer it is, the more it kind of cuts the reverb time, but never actually touches it. It's due to the air. And it's like, it's probably asbestos or something like that. I mean, it's like a lot of these things, like they're just horribly carcinogenic materials were used in the making of these things. So one of the things that you hear in like in a plate reverb is what's called dispersion. And you hear this kind of like whip crack or ray gun sound. It's hard to hear that in like actual reverb. It's almost easier to just synthesize it. It's like, it's the kind of classic like that sort of resonant sweep is what you'd hear. Like if you do an impulse response as a plate reverb, you'll hear that in there. It's a little ray gun sound. Oh, I don't need to update that. And what's cool is that, so that's something is like, what that is caused by is that higher frequencies get less delay than lower frequencies. So you get this sort of natural curve. If you look at like the frequencies, it's like this kind of like the lower frequency, you have a lot of group delay, and it goes down to very short for the high frequencies. And what's nice is because you've got the left and right pickups at different distances, they have different delays at different frequencies. And so the high frequencies for left and right in a plate might be a millisecond apart. Low frequencies, it's like 15 or more milliseconds apart. And what that does, it gives you this really complicated Haas effect. Because it's like, you know, the Haas effect is basically if you have a delay between left and right channels, whatever channel has a shorter delay, you're going to hear it coming from that channel. So it does that, but it's really complicated. And then it's like, so it's going to be like over different frequencies. And then, so like, the echoes build linearly with time because it's two-dimensional, but also builds linearly with frequency. So it's like, it's something that, interesting enough, that's something that digital reverbs are good at too. But they're weird echoes because every one of those echoes, it doesn't delay all the frequencies. So you get a chirp and then that runs through an echo which chirps that chirp, and then that chirp is chirped. So what that means is that, like, if you've got like a 1 millisecond delay in the high frequencies and 15 milliseconds in the low, run that through like reflections a few times, and it's like by the time you hear echoes like in the low frequency, the high frequencies have just bounced back and forth dozens of times. And what we end up hearing that as is just like instant diffuse reverb. It's not like a chatter, chatter, chatter. It's just. I wrote this when I was like working on Valhalla plate, so I was really thinking a lot about plates. But if people wanted me to skip through this, it's not. But yeah, I go into like again the RT60. So it's a lot like the high frequencies decay a lot quicker than the low frequencies, just naturally. Essentially, like for a plate reverb, it's like you have kind of like fixed high frequency decay, and you're just turning up the low frequency decay on it. That's the only way you're really adjusting. Yeah.
You have a quick definition of RT60?
Oh yeah, did that earlier. Thank you for asking. So basically, it's like, you know, reverb time to decay to -60 dB of the original signal. It's a very convenient measure, and it's one that they have like digital stuff for. So, but they often talk about it just in the mid-range or something like that.
Are there any measures that normalize cross frequencies? So if the RT60 is different for different frequencies, is there any kind of over measure that's over?
Usually they just kind of pick a mid-range frequency and go with that. Like around 1,000 hertz is where they commonly measure it, because that's often where like that's. And then it's like rolling off below that. They'll talk about like, you know, but they might even say it like they often just have it in several frequency bands. And that's actually a way that's like, you know, some reverberators have decay that you can adjust in several frequency bands. And that gets you it does give you a more natural sound. Like that same thing where it's like the high you know, like consonants decay away really quickly. And so that's a sound like, I mean, like for like a kind of organic reverb sound, like something that sounds like reality. That's important. And then there were some, like, they used stainless steel plates in the late 70s, and they actually had like a longer high frequency decay. All right, now we get into the stuff I like. Digital reverbs. And this is, I call it the mainframe years, because this stuff, like Manfred Schroeder, he published a couple of papers in 1961, natural sounding artificial reverberation, colorless artificial reverberation. And they showed how to do it to digitize signals. And so you can see here he's doing, like, those things on the left are comb filters. On the right, that's a weird all-pass filter. And we still use these now. I use these every day when I'm making reverbs, like comb filters and all-pass filters and what they call delay lines, which is just that little tau signal, means delaying it. That's used to this day. Now, when Schroeder published these papers in 1961, he said that the quality was indistinguishable from the natural reverberation of real rooms, which isn't true. Like, I remember hearing this in the late 90s, heard this Chowning composition from the early 70s. I think it was Tyrannus. And there's a sound in it that was just bees. It was just a sound of bees, and I realized that's the reverb. That was like, he sent stuff to the reverb, and the reverb was just sounds like bees. When you make something like the Schroeder algorithms, they do not sound, they sound really metallic. But part of that is like, you gotta cut the guy some slack. It's like literally he would have to it would take hours of time on a mainframe computer that you're time chaining with other people to render a minute of sound. And then they'd put that on magnetic tape and they'd drive 30 miles. Like, I think like Bell Labs was in Princeton, New Jersey or something, and then they had to drive 30 miles to where there was a DA converter in the 60s. So right now, if I have to wait 2 minutes for my thing to compile, I get kind of angry. It's like, oh my gosh, I'd like, to like be able to listen to it. So it's like versus like hours plus 30 miles drive and then presumably 30 miles back. So it's like, it's hard to tune stuff that way. So like in the 70s, they started making like dedicated digital reverb hardware, and stuff from out of the gate sounded way better. And the people that developed that stuff, Barry Blesser and David Griesinger, the really big guys, Barry Blesser designed a reverb for EMT. David Griesinger got his stuff. Basically, he was acquired by Lexicon. They implemented the Schroeder stuff. They were really excited to find these papers on this, and then they just like, this doesn't sound that good. But the reason why they were able to figure out, but they improved on it because they designed the hardware to realize this stuff. They designed programmable hardware. They were able to hear it in real time, and then they got on whatever their VT100s or whatever they were using at the time, you know, like, and put in the custom assembly language and like, you know, or machine language or whatever they had for those boxes, and were able, you know, it took a while to program, but they were able to hear stuff and get the quality up a lot quicker. So that's the EMT 250 I talked about. It's about this high. They call it R2D2. It cost $20,000 in 1976. I think the first house I lived in would have cost about that back then. As a kid, I didn't own a house in 1976. Here's the Lexicon 224. It's a lot smaller. It's only about this wide by this tall. Sounds great to this day. Cheaper is only $8,500 in 1979. Now, one of the things about these boxes is that they had really low sampling rates, like maybe like a 20 kilohertz sampling rate, and they had these like filters to cut things out. So the bandwidth's like around 8 kilohertz to 10 kilohertz. It's really dark. You don't hear the high frequencies, but it's kind of a way, like it turns out, as I was talking about with plates and chambers, you don't really hear those high frequencies hanging out very long in natural reverbs anyway. So just not having that sound there is kind of a way of getting around that, because otherwise you just hear this high energy hiss sort of stuff. So one of the things, this is one of the things that makes me happy, because I love this sound, is like they didn't have much delay memory line available. And delay memory line is like the total amount of memory allocated to like the delays in the reverb. And like, you know, because the idea is that you have multiple delays running in parallel or in series, and that's how you get the complexity. EMT 250 only had 300 milliseconds worth, and that was like 1K chips, and there's like 80 of them. Lexicon 224 was 1 second. I don't know what sort of chips it is, but that's, you're going to hear patterns in that. So I talked, well, this is a really tweaky description of delay line modulation. But it's like, it's kind of like the idea is like, if you think about it, like you hear almost these resonances, like metallic sounds tend to be coming from, you hear things ringing. And they're ringing close enough to each other that it kind of bugs you, but not so close that they sound like the same thing. You'll hear a beating between them, like thump, 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 and it's like, it's unpleasant. And so modulation is just kind of like moving those around over time, and imagine you're taking pictures of it. So it sort of blurs a space in between them over time. That's the idea. It can sound great, or it can sound really like seasick. And then I talked about linear interpolation of delay lines. That's really tweaky, but I can give you a little example of that. So let's take like a short, get something kind of like the original Lexicon 224 algorithm. Let's get a sustained sawtooth in there, because that really, single one tends to really bring out. I need to get the decay on that. Am I sending to the right send? Let me just see if that's actually working. Oh, I turned it off, that's why. So let's say like we're gonna have like a fairly long, you know, middle range long decay. And let's turn up those high frequencies, and let's put in the 80s mode or 70s mode. So if you hear it, like, that might be really hard to hear. Let's get, I don't know if you can hear it here, but there's like definite sort of patterns in the sound. But if you start moving the length of the delays.
It's really cranked here. Do you have anything in live?
Oh, hang on, just.
Oh, there we go.
There we go. Yeah, so here we go. Like here it is without any modulation. And let's do one that actually has really short decay lengths. You can hear the metal that way better. Hear that kind of that pattern, it sort of rings out, but you turn up some modulation. And you don't hear the pattern, but you do hear this sort of like lush sound, and then it's like, you know. It's a really nice sound. That same thing, turn off the modulation. So that's what the modulation is doing. It isn't designed, it wasn't intended originally to, I can even show you an algorithm based on the original EMT 250. Let's shrink that size. Very ringy. Very lush, but getting kind of seasick. It's like, so you have to sort of dial in the right amount of modulation on these old boxes and on things that emulate. But it's a way of cheating. That's like, this is using about 300, 400 milliseconds of delay. It's like, and you can hear the ringing in there, but like you turn on the modulation, that goes away. And so, I think I talk about this next. You'll get some noise coming out. You wouldn't be able to hear it over these speakers, but just trust me, you do. It's subtle, but it's one of those subtle things I think people like. So 80s, digital reverbs were everywhere. Everywhere. Turned up, gated reverbs. They were stopped trying to do anything natural with it. It's just totally unnatural sounds, and you put them on everything. And I don't, it's not really my thing, but if people like it, then I'm happy to provide the tools for them. So like this is like a Lexicon 224. It had rich chamber and rich plate, which were new algorithms. It didn't have rich hall. If you know that joke, you're a certain age. 480, Lexicon 480L, it's kind of like the 224, but it does some randomization in there. And so those don't have the chorusing. I can actually play an example of that. Like, so let's go to like something that's more like the, something more like a 224 type algorithm. I'll put it into 80s mode. Get the GUI all 80s out. And then you can hear the, let's make it a little bit not absurd. You got that lush chorusing. For some reason in the mid 80s, David Griesinger decided that chorusing was bad, so he did a different sort of modulation, which changes things over time, but it doesn't really give you the pitch change. Like, I'll turn that off, you can hear it. It doesn't sound that different, but to some people, that's the sound they really love to hear. I personally prefer the pitch modulation, and it still had 18-bit integer processing. Those 2 bits make a big difference, but not that big a difference. The converters made a big difference. Quantec, it's a cool picture. I've never seen one of these in my life. I've never encountered one of these in person. People rave about them as like being really realistic. They use a lot more delay memory than the Lexicons and the EMT, but again, don't know where you'd find one. RMS 16, they did their own algorithms, but one of the things about like the old reverb hardware is that nothing in there was copy protected. That code, you could just sit there and read a ROM and then spend the next year trying to figure out what it did. And so AMS, they probably, like people say that, like I heard from some anecdotes, someone like delivered a Lexicon to the AMS folks, and then pretty soon they started getting their stuff together. So they probably sort of figured out what Lexicon was doing. I hear it doesn't sound the same, but it's like, it's the basic idea. They have a bunch of all passes in a series with a feedback around it. Nonlinear reverb, that was used, they would based it on this Phil Collins drum sound, and it was huge. People love that thing. So this is where it gets interesting. It's like there's a lot of 80s real reverbs. They're just not trying to do anything realistic at all. Like the nonlinear reverbs, that's like it's reverb and then they just cut off the decay. Reverse reverbs, it's like what you get, like they used to do these in the 60s by like recording something, reversing the tape, running that through a reverb, recording that result, and then flipping the tape again. So the reverb comes before the sound. So there's ways of doing that where it's like you get a reverb that builds up over time. Super modulated reverbs. And then there's shimmer, which is like, it's a reverb in a feedback loop with a pitch shifter. And that, let's see, that's easy to show. I have a product that does that. So without the feedback, it's just a really long reverb. Very modulated. You can hear the kind of seasickness. And then you turn up the feedback, you can control the pitch shifting. And it sounds like a planetarium.
What?
A planetarium.
Ah.
It's kind of instant planetarium, like those techniques. So 1990s to today, like there's a lot more that you can do. I didn't really talk about convolution here. Convolution is really awesome. It's like, I don't love the sound of reverbs done with it, but you can do like all sorts of really cool things with convolution. And like, it's free in most DAWs now. So like, but for the most part, like, you know, because computers get more powerful, they're trying to go for more realistic sound, like more early reflections, lots of memory for the late tail. Like TC Electronics and Bricasti, they're often trying to go for a sound that doesn't sound like there's much reverb in there. So they're putting a lot more work into having something that's so good you barely hear it. And it kind of glues things together. So this is where I get really tweaky and just talk about how these things were done. I'm not sure where I got those symbols. It might be Rudolf Koch, The Book of Signs. That's a really neat little book. So this is something that's like, you know, because like Randy, like you came from mostly academic, or was it, I don't know how to call it, it's like academic but cycling 74. Like what's like, that's like,
Yeah, they have some closed source property, but they're pretty open about things for a
yeah, but
privately held company.
but it seems, but they're very like there's a lot of like what stuff, and like there's heavy links between like, you know, Max MSP and the academic world and stuff like that. So like one of the things about like, you know, there's academic published speakers, but like physical reverbs, there's never any mystery. It's like, how does a reverb chamber work? It's like, go into the room, just check it out. You know, how does a cathedral work? It's like, well, spend 100 years and several generations of craftsmen and like most of the royal, I don't know how they did it, but you know how it's done. It's like, so first software reverbs were published in journals, but ever since 1975, they've kept a lot of this stuff sort of secret. And software inside, like, it's not easy to reverse engineer, and you know, you can reverse engineer, but it's not easy. And if they patented it, it's like, well, you're just telling people what to do, and then you just change a few things and you've got your own variation on it. Or you can do that and like something that's patented, and who's going to prove that you did that? So it's like there's not much incentive to patent these sort of things. So there's this point where and this is a little bit less true than I was when I wrote this in 2015. It's like there's reverb development in all sorts of academic places like Karma, MIT Media Labs, ERCOM, and they often do a lot of work around feedback delay networks, convolution, and physical models. This is a feedback delay network where it shows a bunch of delays at z to the minus m going into a matrix. And they're great, but commercial reverbs sometimes use that, a lot of times they don't. But like FDNs have been used since they were published by Stoutner and Puckett in 1982. But there's a lot of good reverb algorithms that happened before that. And so this is like, it's kind of like archaeology figuring it out. I was an archaeology anthropology major, so I'm just probably going to say it's like archaeology, just like other people might say it's like gardening or cooking or whatever, but that's the metaphor that I live within. So you can kind of like figure out what's going on, like archaeology, you can figure out what's going on, but the people that do it are either dead, like archaeology, or they've signed NDA so they don't want to talk about it, or they're still making money about it. So you can guess, but you might get it wrong, but sometimes if you guess wrong and it sounds good, whatever. A lot of them were like, these are the people like Chris Moore, Anthony Angelo, Wolfgang Buchleitner, and then what's that? David Griesinger. They had a lot of, there's very long beards going on.
They were ahead of their time.
I know. Well, when I first started like doing reverbs, it's like, whoa, they all were bearded, and I was clean shaven, and everyone I knew was clean shaven, and now, yeah.
As your reverbs get better, your beard grows, or as your beard grows, your reverbs get better?
It just looks better with a beard. It's like, I'm just used to it. So I just like, I've read everything, like, you know, there's a lot of papers on the subject. This is just talking about, like, this was someone gave in a class, so it's like, you know, for people actually interested in the reverb design. So I'm like, what I'm things I like to figure out, it's like not just how something worked, but why someone was doing that. Like, it's important to me that David Griesinger came from a classical background. He was always trying to make something that sounded like Boston Symphony Hall. So if you look at like, oh, whoa, there's these taps from the network here, do those map to some reflections of Boston Symphony Hall in one seat or something like that?
What did John DATTORRO do? Or what was his main?
John DATTORRO was, he published a couple of papers in the journal of, in the AES. And the first two, like it was a 3-part article, the first two came out in 1997, and the third one came out 10 years later because rumor has it that Lexicon basically got really mad that he had published these papers because he had worked at Lexicon and then left. And then he, and then he worked at a place where they reverse engineered a Lexicon reverb. And then he left that place and moved from, that was in Pennsylvania, moved to California, and they sued him. And there's this whole thing about like intellectual property is like in stuff for hire. And it turns out that in Pennsylvania, if you do work for hire, you can still talk about it. Like, it's not like out here, it's like if you do something for hire, I don't think you can speak about it at all if they don't want you to. But so he talks about this. Like, this is on some obscure corner of the internet. That's the 224 concert hall. It's really weird. And that's a really weird drawing of it.
Are these circuit diagrams, or what is this diagram?
This is what you see in DSP networks. Yeah. Like, so like it's easier just to point. Like, oh. Is that the microphone?
Sound like.
Am I still plugged in?
If you weren't expecting it, it's probably the mic.
Did I unplug from the?
Should be all right.
Okay. Like, it's hard to see, but like that right there is like represents like a delay line of 239 samples. And then it shows like you're adding them, you're multiplying them, and like the order in which these happen kind of shows you like the feedback network. Like, this is a 1-pole filter, this is a weird 1-pole shelving filter, and then you see like these things like, you know, if you've learned enough of that, you can say like, oh, these are nested all-pass filters.
Are they all stereo? Is that what the crosses are?
The crosses is like, well, like there's input injected in the left.
I have the proper thing for this.
Oh, perfect. Thank you so much. Wow.
That's impressive.
Like, I think it's hard to see here, and I'll post this so you can see it, but it's like, but I can also tell you where the link to it is. Like, input comes in a certain place, it's summed in, like it goes through, like it's filtered, it goes through a couple of short all-pass filters, it goes through this longer all-pass filter, which is nested. There's an all-pass delay inside of an all-pass delay. I say longer, but it means it's like an all-pass delays. These are all-pass delays. This right here is 3 all-pass delays nested in there. The shortest one, this thing indicates you modulate it. Then this goes into this network over here and does a similar thing. These are actually identical, just different lengths, but it's not drawn that way. And then this here, you can't read it all, but this shows you, it's like, okay, like the outputs from this network, like you take a output out like from here, somewhere in that delay, and then somewhere in this delay, and then somewhere in this delay. And then same here, like bam, bam, and bam. And then there's also like, that's like for like, this is like left comes in here, you take 3 left outputs, and you also send something from here to the right. And then vice versa here from the right. But this is something he hasn't even, like, you know, this is stuff where it's like, you know, when I saw this, I recognized it because I'd kind of done some research on this stuff. But it's on some corner of the internet. I don't know how many people know about it. This is the one he published in 1997. He called it In the Style of Griesinger. And he's just talking about this idea of like, I call these all-pass loops, which is that like you have like just like a bunch of all-pass delays in one big loop, and then you take the outputs out from some of them.
And that's the alto one, basically.
This one?
Yeah. Because it was available from that source, and
Yeah.
it sounded pretty good.
It's a great sounding reverb. It's not, I don't know if it's actually based on any particular, it might be based on one in the 224. It's about half the complexity of like most of the 224 reverbs.
Yeah, it's simple.
This one here, like Keith Barr, rest in peace, he was the founder of Alesis. He's also the founder of MXR. He did a lot of stuff. And he was like, near the later part of his life, he was really open about how he did this stuff. Which is just like, you can see, it's like, comes in, goes through a couple of all passes, like left and right goes out, like control reverb time. It's like, it's really what it is like 2 all passes, 1 delay, control the reverb time, 2 all passes, 1 delay, control reverb time, repeat as necessary. Usually you'd have some sort of filter for those 2, or some sort of more complicated filter. And those, it's like they sound different than the Lexicon reverbs, but I love the sound of the Alesis stuff. I listened to so much music from the 90s that used Alesis reverbs because they couldn't afford, like any of the like the Warp music bands, they couldn't afford Lexicon stuff. I mean, like you look at their gear now, it's like, oh, how can they afford that? It's like, well, those Roland boxes were $75 or something.
It was bedroom music.
Exactly.
So they got like big, and then they could afford production studios to go to.
Yeah, now these people. Exactly, and like like the MIDI Verb 2 and the Quad Reverb were huge in the 90s. So much beautiful music done with those. I loved it too. And then this is another drawing of the same thing. It's like an all pass delay, tap out after each one. Although I really find like the Keith Barr one is much better because there's like all passes and a delay. Because if you don't have a delay between the all passes where you tap out, it's just weird. You get some artifacts because you've got like this getting very tweaky, but this right here is the feed forward path. So if you have the input here and you have a feed forward path of 0.5 and a feed forward path of 0.5, right at that node, you'd hear just the input signal with a gain of 0.25. If you run through a bunch of those, you're just going to get some weird coloration things going on. So a lot of, okay, this is less subtle hits. A lot of commercial reverbs have all pass delays within a larger delay loop. I call them all pass loops. They've also been called all pass rings. They often have a lot of series all passes for the echo density. Some have less series all passes, but higher numbers of output taps, where like they tap from the delays between them, or they tap from the delays within them. Nested all passes, that Lexicon 224 used it. Those things sound cool, but they they're just sort of inherently ringy. They're not super stable. And I've just found that all pass loops, you can get them sounding quicker than FDNs with, like, they're not as tweaky about like the delay lengths. A lot of these things, like, you have to have the right delay lengths, and like an FDN is like the matrix you use has an effect on the delay lengths that you can use with it. Like some sparse matrices work best with random delay lengths. Do that with full matrices and it sounds horrible. So again, I gave this a class where I was talking about designing these things. It's like, I've written hundreds of these, and that sounds like 16 years. At this point, it's 20 years. I need to correct that. And most of them were horrible. Like, that's really how I learn, is just like get to the point where I code these things and just like find out what is bad. And a couple of them are okay. And then it's like, but by learning, like, I like to mix and match things. It's really nice to like mix, like, you know, you can mix feedback delay networks and like the all pass loops. You can do all sorts of stuff.
What do you code in? I know nothing about DSP, so.
Okay. Oh, what do you say?
What do you use to code?
Oh, I use like C++ for the most part. I've done a few things in the past in assembly, but it's like my stuff is C++. I have my own low-level DSP library that's fairly simple. It's not even fancy like C++. I basically use it as C with classes version of C. So it's like the functions, and like, you know, I don't do a lot of, like, I think because I'm coming from, like, I came from the embedded world where they just wouldn't even use C++ forever because they didn't trust the accuracy or like the speed of it. So, and then I have some customized like SIMD intrinsics that I call.
Do you use anything like Intel's vector library or Apple's vector library?
I use Apple's vector library. On the PC, I just use I use like the Intel like SSE intrinsics, and I don't use that much of them. I mean, I can even show you that if you're interested in that. Like for example, like my vector library is really simple. Oh wait, I need to commit some files. I thought I did that.
Well, I guess those libraries don't really have a lot of reverb. They have convolution and they have FFT, but they don't really have a lot of them.
Well, like for example, like this is like I have a vector library where I just have an input, output, and I have the block size. And some of these I'm like, that one is not even vectorized, but like in some of them I'm calling like the accelerate functions. I'm really happy I'm doing the accelerate in case Apple ever pulls the plug and just moves everything over to ARM, because they have the accelerate library on ARM already.
Yeah, they had it for PowerPC, and when they went to Intel, you just same function.
Exactly. It's like because I used to do stuff for PowerPC as well. So if they do that, technically it's not going to hurt. It's just more the business model I worry about. And then for I'll even have my PowerPC library there. I could get rid of that for this plugin. I'm not compiling for that anymore. And then for like Intel, you can see I'm actually calling like the intrinsics, like SSE2 intrinsics for stuff. But like most of that stuff I programmed back in 2010, 2011, I've just been using it since. There's like, it's like once you figure out how a multiply add happens, and there's just a few things. There's very few things like, fractional. There's very few things I need that's like actually requires any, like reciprocal square root is neat. But like you just call that on the Mac, and that's just great.
You mentioned that you had a lot of algorithms that you didn't like.
Yeah.
How long would you try and fix it or work on it before you would just...
Oh God, sometimes I forget. Sometimes I forget why something sucked. There's other times I'm like, you know what, there's something really good in here. So like, I mean, there's this one like this way, it's like, I've done like the 2 all passes, 1 delay stuff in the past, and it's just like, that's not that good. And it's just like, for that particular one, it's like I figured out some good math for generating the all pass lengths and then some other ways of tuning it. So, but all my stuff before that, like I've had other ways of doing that, and they just don't sound that good. And you start like, I hear much more, I mean, like, I'm sure my senses are, like my eyes are worse than I was when I was 20 years ago. But my ability to hear reverb artifacts is much better. I can hear like the patterns and stuff like that. I can hear like weird resonances that I don't like. So, but the problem is when you come up with things, like sometimes you just keep coming back to ideas, and it's like, it's like my ability to kind of like know how to tune them has evolved, but then my ability to hear the problems of them evolves as well.
Also a related question.
Yeah.
Listening to reverb, it can be pretty subtle.
Mm-hmm.
How often do you take a break, or just like you're working on something, listening, and then just, I don't hear the difference anymore?
I don't know. It's more like frog vision to me. Like a frog, it's like what you end up here. Like frogs, like my understanding of frog vision is that they will look at something and just stare up at it. And eventually everything fades away. It's almost like anything that's not moving fades away. So if anything changes in that environment, like a fly moving across there, that's what you see. So it's like when you're hearing things over and over, it makes it like you're not actually hearing, like what you start hearing is you're not hearing the same thing over and over. You just start hearing the differences over time. But then at some point you have to stop and your ears hurt. But then you start again the next day. And I've actually taken pretty much 3 years off of designing reverbs. So, although back in early 2017, at some point because I'm working on this new product, I just took a break. It's like I wanted to try to tune, make a really natural sounding reverb. And I remember I just took like a month and just went through hundreds of algorithms, and they sucked. And then I came up with one that sounds good. And so after I get Valhalla to lay out, I want to try that. You know, it's like actually go back to that. So it's like that's kind of on the back burner. But it's like you know. So I spent years and years on it, but I spent the last 3 years doing mostly other stuff. So
Do you prefer headphones or monitors?
speakers, headphones are gonna like I have monitors. Headphones just end up hurting like hell over time. It's like that's the thing. Is like, I mean, just even the pressure on the ears ends up kind of itching, but like you can really get ringing if you listen to at least I do. Whereas like with speakers, not so much.
What kind of speakers or monitors do you prefer? Like what brands?
I have Mackie HR824s, but I think that my company I used to work for bought them for me back in 2001. I've just used them since. When I really want to tune in something final, I go to Don Gunn's house. He's a local engineer, and he has a studio in his place. And he always changes out his monitors, but he used to use Genelecs. They sound good, but his space is really well tuned. And that's something too. It's like I just assume like I have mathematical things I know how to do, but when I do the final tuning, I want to go to a space that is acoustically really nice. Because otherwise, it's like, you know, otherwise you might just be like tuning to some reflection that's over here or something, and it really throws off stuff when people hear it. Or it's like, you know, just the frequency balance is not good. So I could probably use better speakers at this point, probably smaller ones, but I haven't.
So, I mean, I've read your bio on your page years ago, and I bought all your plugins, but why reverbs?
I don't know. I mean, I guess like one thing.
Because you've been doing it for a lot. You put out a bunch of reverb plugins.
Yeah, it's like so. I was really interested in computer music, like the concept of it. Like I remember like when I was an undergraduate, I never became a graduate, but when I was like an undergraduate, like I really wanted to take these computer music courses, but I was just intimidated because it's like there's like 16 people in this course. And when I first started out, it was on like, you know, 1988. There's like a whole bunch of VT100 terminals, and every terminal had 2 speakers on it. All those speakers connected to the same DAC in the basement. So everyone, like, there would be one person like that could be listening to music at a time, and so you either listen to that or you turn that off, because there's like they had like a PDP-11 as well as a like refrigerator-sized computer, as well as like a custom digital processor that was also refrigerator size. So that's all they had, and like it was, which also means like it was a very collaborative environment. It was like in this really nice building. It used to be the former university president's mansion. It's up on this hill, like all these people doing that, and it was really like, you know, just so people would listen to each other and all that. But I didn't have I wasn't a double E. I was kind of intimidated by that, so I only took some of the courses. And then, but technology changed. Like midway through, they started replacing everything with Next computers, like the cubes. And so, mid-90s, people were starting to use they'd still have this like non-real-time languages. Like it still would take time to do it, but you could run it on a PC, like originally a Linux PC, and then just a PC, like running Windows 98. And so, like I end up taking this year-long course at computer music at UW, talked my way in there. But one of the things, like I really love the sound of granular synthesis. Like they would do things where they had like 100 randomized grains processing the sound, extending it over time. I love that sound, but it's like also like, you know what? I could take these 4 delay lines and feed them back on each other and modulate them and feed a sound into that, and you get a sound that can last almost as long, that has really similar characteristics. So I think from the get-go, I was always interested in kind of the compositional aspects of it, and also just the sort of cheating of it. Because like, you know, four delay lines, even back then, it's like, okay, press compile, okay, you're done. The 100 grain granular stuff is like, okay, for a minute to a couple of minutes of sound, like press compile.
I mean, this is like Curtis Rhodes type C-sound stuff.
Exactly.
And then just like trying to find like the hack to like, yeah, I want to like fuck with the same stuff, but quicker, like dopamine reuptake.
Exactly. And it's like, I mean, it's like, and like these, like, I like that sort of like, I mean, I really like that, like there's a, definitely there's a kind of school of computer music that was much more Wagnerian. Like, you know, you had like tons of complexity. It's like you'd have thousands of grains, and you'd have like hundreds of oscillators, and they'd all make this stuff. It's like, you know what, like there's something about these recursive algorithms that what we call reverb that was used for reverb algorithms, but could just be abused to kind of create these sounds. Now it turns out it's like this wasn't like I was inventing anything by that. It's like, you know, whoever could afford a Lexicon 224 in 1979 was doing similar sounds. Like the dudes in the early 90s with a quad reverb were doing similar sounds too. It's like selected ambient works is basically a couple cheap synths through a quad reverb, and you just crank up that reverb time. So they're doing sort of similar compositional things, but it was just like, you know, kind of like learning these sort of like things with it. But it turns out that like you don't like, you know, one, people don't necessarily like, people like to buy the some simpler things, but two, the simpler things can get kind of crazy. Like a quad reverb is kind of a commodity thing, but you can get really that sort of complexity out. And even like when several years back, people were into pulse stretch for massive time stretching. It's like, it really, it's like, okay, it's this massive sound that fades in over time and fades out. And it's like, you know, it's like, and that does with like giant FFTs, and it takes like it, you know, it takes a lot of like CPU to do that. Well, it's like, you know, just take something like this, turn up the diffusion, turn up the size. Well, it takes a little bit of time, like that delay, because it's tape based on tape. So let's try like. Let's even just clear that real quick. Takes a little bit of time. Do something where it like actually fades in over time. So it's like. I mean, it does a very similar thing to pulse stretch, which is like the artifacts you find from taking huge FFT windows and windowing them is very similar to what you get with just having a bunch of series all passes and modulating the delay lengths a little bit.
So it sounds like it started out where you found this hack, this thing you were interested in terms of granular synthesis.
Yeah.
Like this Curtis Rossi sounds like you found this hack that you were like, hey, I could do this faster, I could do this like kind of. But then reverbs, just having hit on that, remained interesting up until like recently, where you're like, God, I really should do a different plugin.
Yeah, I mean, and there's so much, and the plugin does some reverb too, and it's like, but but there's something about the mathematical nuances of it, because there's no one right solution.
Sure.
And there's so many factors. Even if you have to say like we're doing a 16 delay FDN, it's like, what do you set the delay lengths at? What do you set the matrix at? You have so many variable, like what's the modulation? There's so many variables, and like just playing around with it, it's kind of like I don't know, I've never played Sudoku, but like some you know, like chess, it's like some sort of mental patterning thing, and you can just always work on it. Mm-hmm. It's like I go for walks through Ravenna Park, and I'd be thinking about, oh, well, if you do this, this, and this, and like it ends up being like, there's just so much you can do with it, and they sound and hopefully things sound different. I mean, I'm hoping that. I mean, it's probably like, you know, a lot of the things end up sounding the same. You have different approaches to get similar sounds, but it's, I don't know, it just ended up being like there's a lot mentally to work on, and I also like it because it's kind of, I like stuff that's born obsolete. Like my dad would in like his job was like in the 80s and 90s working like, you know, kind of recruiting people that knew technical skills, and back then it was kind of scary because it's like as soon as like people hit their early 50s, the jobs started drying up for them. And it's like, you know, because it's like there was massive evolutions. Like, we're not using COBOL anymore. We're not using mainframes. It's the AS400. If you don't have AS400 skills, whereas like I'm working, some of my reverb algorithms are based on designs from 1975. That's been obsolete forever, and it still sounds good. So there's something, I really like working with a technology that is inexhaustible, and it's not as like much about like being in the moment and cutting edge. It's like obsolete DSP still sounds great.
Mm-hmm.
Yeah.
When I run the reverb plugin in live, it works really well.
Mm-hmm.
And then I never really liked the sound. It's always got a grainy quality to me. It doesn't work. And then I'll use like the waves, play reverb, and it sounds great, but it wrecks my CPU and I can't run it. And then you talk about these old hardware boxes that have so little processing power built into them. I'm just wondering what your general thoughts are on processing power, applying that toward reverb algorithms when it's necessary, when it's helpful. You know, I don't know, just
It's, well, I mean, like one thing is like the amount of CPU is not necessarily proportional to the quality of the algorithm.
Right.
Like for example, like I'd say like in the Valhalla vintage verb, like in a given algorithm, about half of the CPU is being applied towards the cruft. Like, you know, it's like you have to do work to make it sound like a 16-bit algorithm with a 12-bit converter. You have to emulate that stuff. I mean, I guess I could program in 16-bit fixed point, but I'm not going to do that. It's like I'm not going to be programming in MMX or whatever that is. So it's, you know, like, so there's a lot of work trying to emulate these artifacts. And then something like the waves thing, like I'm pretty convinced that the waves plate is actually convolution of the stuff at Abbey Road. And most of the CPU is going towards modeling the analog inputs and outputs. Like that's happening real time. They've got saturation, because if you turn those off, the CPU goes way down. But I'm not sure what they're doing with their CPU, because it's like a lot of their stuff, it sounds like what I call time invariant, which means it's not changing over time, which means you could do it with convolution. So, but you know, I think that's the whole thing, is like if you want to get real, like there's, for example, like the Bricasti reverb uses, it's far more powerful processing than this. But then, you know, then all of this applied towards one thing, like all the cores. But the question is, do you need that? I mean, like if it sounds like it, I mean, like there's all sorts of ways of getting the different sounds. And it's like if it's like, you know, like if you could do some technique that sounds like that at a fraction of the CPU, and it sounds like it, then it is it. Because none of it's real. None of it is like actually modeling a real room. That's still several orders of magnitude beyond what this can do. Like modeling every reflection in a room in real time would just be prohibitive. And no one's doing that in real time. So it's just, you know, I think it's more about like, I think the CPU thing is like some people might, you know, there might just be programming things or stuff like that. But I think so much of it comes down to the philosophy of what they're, you know, of what they want to do. And I think a lot of it is not towards the reverb itself, but modeling the kind of, emulating the analog saturation stuff that's around it. Or like, for example, like Universal Audio, they're exactly emulating the artifacts of the 224 at the original sampling rate, which is like 20K. It's really hard, like you can, like our machines run at 48.4.1, 48.96. They don't run at anything that evenly divides into 20K. So they're doing some very complicated sample rate conversion. So that's part of what's going on. It's like a lot of these people are trying to get things exactly, where I'm just like, it's close.
Are there any that you really like that you haven't been able to achieve, or any that you don't like so much they're not even funny?
I won't talk about any of the ones I don't like. It's like, you know, it's like everyone's got like different aesthetics and all that. I mean, like as far as ones I mean, and achieve, it's like some of them are getting close. I mean, I have a Bricasti. I haven't listened to it much because I've been working on this delay. I really think Exponential Audio does really clear sounding stuff. That's Michael Carnes. He worked at Lexicon since 1989 until like I think 2011 or something. They parted ways, and so he formed his own company. And so he's doing things that they're Lexicon-ish, but they sound clearer. He doesn't have to make things sound exactly like what he was doing there. So I really like those. And I think there's other really like creative, like, I mean, I love the Fab Filter reverb is clear sounding and its GUI is beautiful. There's, you know, like I think, but there's a lot of it has to do with like designs. Like I'm excited to hear Randy's 3-knob thing because I love stomp boxes. I love things that are simple. So that's part of it. It's like I tend to be like lose my interest when something has like 50 controls or whatever.
How many reverb, like hardware reverbs, did you own in your lifetime?
I don't know. I've got, like, I think I had like 3 Lexicons at one point. Part of it is like I couldn't find these things. It's like, you know, it's like, I mean, like you'd rent them. It's like I'd go rent like a 480L. And at the time, it's like, you know, I was not going to pay $4,000 to buy a 480L. You know, like I'd rent time in a studio that had a 224XL. You know, stuff like that. So, you know, if I've owned.
If you're renting time in a studio, how long do you need to understand it or
Well, you go in like I went into the studios kind of having a pretty good idea. So it's just like I was like able to just like really do hardcore. Don Gunn was with me. We'd like spend 8 hours or whatever. We'd like at the end of the day, just like your brain is fried. It's not like doing that sort of listening is not fun at all. It's just like, because it's not like you're listening to music. You're listening to just like little signals and stuff. And that was one of the things, like, I mean, like I remember doing that in 2013 with Lexicon 224. And that's when I figured out like there's this one sound. Like, let me see if I can duplicate that. That just freaked me out, like when I was actually starting to hear the sound of the modulation. And it's easiest just to do it, so let's get the oscillators out, get a sine wave set up. So let's get the attack. Let's turn. It's hard to hear in here, but there's like, you start to hear these things like, I'm like, let's see, let's do it in 70s mode. Yeah, oh, let me turn down this stuff too. I can't really hear it in here, but if you're hearing it over good speakers, it's like, it almost sounds like a modem. So that's the sort of thing where it's like, like start figuring out like, oh, it's a modem. It's like, oh, that's because no matter what's going on, they're using a Z80 to generate the modulation, and that's an 8-bit processor. So it's like the modulation signal is 8 bits, which ends up creating like crazy quantization noise of its own sort. So that's the sort of thing, but it's like just having to go in and just like, knowing enough of the theory and reading the service manuals, and like, so you're making those 8 hours at whatever the rate is count. So that's more what I did. Like, I own stuff and figured stuff out, but there's like a few things that's like, would just rent and all that. Yeah.
2 questions on the stack. One is like when you're doing vintage, do you find yourself having to prioritize between emulation and just sort of beauty, like emulation and your preferences in that? Did you sort of choose best of class or like?
It wasn't even necessarily best of class. I mean, I knew I wanted to get that kind of like older lexicon sound, but there were preferences. Like I remember I rented to 480L, and like the one we rented was like had earlier ROMs. Like the one I could find in Seattle didn't even have like the most recent ROM, so it was missing a fair amount of the algorithms, but I could hear the random hall. It's kind of like, It wasn't, I mean, it didn't really impress me that much, whereas like, I heard like the earlier 224 in a studio, and and I worked with one in college, and it's just like that sound to me just spoke to me. So it's like my stuff, it's like, it's gonna be not necessarily the most realistic emulation. It's like, I want it to sound good to my ears. And then a lot of things, it's like just doing it for like, look, like these old things had these like multi-slider hardware interfaces. And like you can do stuff like, oh, like with a couple of fingers, you can adjust like the low frequency reverb and the high frequency like decay time, like low and high decays, and the crossover between them just with a few fingers. And it's like, you can't do that with a mouse. So it's just like, I changed how things were mapped so like the controls would work with that. And then also just like, what controls can I gang together and leave out? It's like, a real 224XL 40L has like so many more controls than this, and you just have to like, you step through them on menus. And it's like, I want everything on one panel, and like, not have to step through stuff. So a lot of it is like choices made towards like, one, my own aesthetics, and two, like simplification of the interface. And then, you had another question?
Yeah. What about your business model? I mean, like multi-verbs, like $1,000, and you have the most probably in-demand algorithmic ones for $50.
I don't know if they're the most in demand, but thank you. I think that like part of it was working. Like I designed a reverb for company Audio Damage, like that, like this license through them, and their stuff was like $39, $49, and that's actually how I came to see them. It's like, it's like I didn't have a lot of money, and it was something that I think there's something of just like one, but it was also something that's like, they talk about a disruptive business model, but I wasn't thinking about that. I just basically, it's like, I remember I interviewed, it was like we moved back here, like I was working remotely and then got laid off from my job, did contracting, but around like 2008, the economy started drying up. So it's like, okay, I was like, I will go like interview for like a video game job at Microsoft. And like I remember like, you know, doing sound. I remember they're like, hey, you can go home early. That's not good in a Microsoft interview. I wasn't able to move the trains correctly or whatever it was, that question, like the little Martin Gardner question. But so with that, it's like, so I really, it's like the $50 one is like, well, there's no audio industry around here I can work for. I could go get like a more junior job probably at Universal Audio, but the money I'd make would be more than, like, look, both my wife and I would have to be working full time. Someone have to watch the kids, and like whatever money I'd make would be offset by the cost of living in the Bay Area, which is just so dang expensive. So it's like, it's kind of like I had nothing to lose. I had like literally nothing to lose with like doing my own company. And it's like, well, you know what? If I have nothing to lose, then it's like I don't really have any particular motivation to like price things the same as other people. It's like, because like that doesn't help me. I don't make any money if they sell it for $500. So, I mean, it was just basically like, and probably just like, and then also it's like a way of like, look, it's like, my GUIs, they didn't look photorealistic or anything like that. It's like, look, it does this. I don't want to promise too much. So it's like, it just seemed like a right pricing point. I mean, plus, I've worked for, like, done some work for a company that had a similar pricing point. So like Chris Randall and Adam Shop Talk definitely were an influence on me for that.
Thank you. Did you do that Rat Shack?
Thank you on different levels.
Oh no, I did EOS.
Okay. Rat Shack.
Yeah, Rat Shack was Chris and Adam doing on their own.
So what is the difference between the 70s and 80s mode here,
Oh.
really, just in a nutshell?
Well, it goes back to that stuff I was talking about. Like the 70s mode, it runs internally, it's downsampled. So it's like running internally at like half, like at, if this is running at 44.1 kilohertz, this will be running at 22.05. And then, which has a big effect just right there in the high frequencies. There are nothing above 10K. But then there's stuff like I'm using, in the 70s and 80s modes, I'm running linear interpolation on the delay lines, which basically gives you a sort of low pass filtering that's dependent on the sampling rate. So 80s mode, that sounds kind of like, in 80s mode, it's like, it makes it a little bit darker. In 70s mode, that linear interpolation makes it a lot darker. And then in now mode, I'm running like a much, just a all pass interpolation. So it's very smooth, like no high frequency loss. This is the original GUI of it. People are like, it hurts my eyes. It's like, well, that's kind of a clue that's like, that's what it sounds like. It's like, it's very, I just want something that's just black and white. There's like, this really, like, there's no loss to it. There's just, it's colorless. But then I realized that, like, okay, black and white, this way looks colorless, and people won't complain.
There's gray too. There's gray.
There's gray, I know, but I really want, like, originally it was blinding white. I've learned my lesson. People don't like blinding white GUIs. People like, I'm not going to use the now mode because I'm like, well, I'm going to use it anyway. I don't like the sound of it. I put it in there just so you have it. But I've learned it's like, it's not like, this is not my thing. This is like, I make it, but it's like I'm trying to make something that people want to use. And it's like, well, let's make something that still gets the idea of no color, but doesn't hurt your eyes when you look at it. One of those valuable lessons I've learned.
So you said when you were in studios and stuff, mainly you listened to like impulses, but like short sounds and things like that.
Like, and vocals, but like, we'd have like stuff with like sine waves and stuff like that.
Get someone to come sing or play a guitar or whatever.
You want the same. You want a sample. You want the same thing played over and over and over again. Where it's like there's like that one little place where the singer's voice cracks. You want to hear that the same every time, so you can tell what part of it is like, because maybe it does something special there, or maybe it doesn't. And you really like like I've listened to Tom's Diner like 10,000 times, I'm sure. I still don't know the words. I'm like, it's so weird. It's like I'm sitting there. It's like, I am sitting in a corner at the hum. It's like, I should know this. I've heard it like so many times. But yeah, it's like you listen to the same things. But it's like it's a combination of like kind of developing the stuff, like sine waves, same vocals over and over, dry musical signals, impulses, and then once you start getting it live, then you have to listen to more material and like hear how it works with like a bunch of stuff.
Do you ever use like spectral analysis or anything like that to kind of see what's happening to the sound?
Sometimes I really like. I tend to do the simpler version, like a Fab Filter. Which is it? Has just a built-in spectral analysis mode. Oh, that sounds bad. Hang on, sorry. So it's I find this very. Wow, that's a lot of modulation. Hang on. But like you can see, like it's very useful for some things. Like you can see, like like just running a sine wave through it. You can see that peaks are moving around and all that with the modulation. Whereas like if you turn the modulation off, it looks different. You get a little bit of tiny motion, but it's like I find like that's the sort of spectral analysis I might do. Whereas like if I'm, and then it does really useful things. Like they put it after shimmer, and you can hear an artifact in shimmer of like how I did noise reduction. Or you don't hear it, but you'll see it. Hypothetically. Oh man, I'm not seeing the right one. Oh, there we go. Okay, be that way. I don't know why the spectral plot stopped, so let me just bring another one in. Oh, because I'm not running a signal through that. Oh. Like that's something to tell, like, oh, well, there's a lot of like low frequency noise going on below the signal itself. So like there's like spectral plots are very useful for analyzing things, but often for hearing, like for seeing stuff that you wouldn't hear, or like seeing, like, for example, oh, look at this. It's like this sine wave here, instead of being like a peak, has a much wider skirt, and that tells you stuff about like the noisy processes and all that going on inside of it. So yeah, spectral can be very useful to like kind of suggest things, but you still have to figure out what it is using your ears and theory and all that. By the way, let me just see if I have any more slides that are like important. I think we're getting like this is a design like I was talking about. Like this is an FDM, but it's got the all passes in it. It sounds pretty good. I listen to everything, like, like as far as getting stuff, because like, like there's what I do, but then there's also like, getting feedback, and having several products is like you have more people listening to it. I love surveys. I don't know if you noticed, I didn't mention forums in here, but like I have a survey, and it's like I've had thousands and thousands of people respond to it. Versus like in a forum, it's like you'll have like a few people say like, well, general consensus is like, you mean you and those two other people that are just posting, that each have 20,000 posts. And so that's something I've like learned, just like, versus like surveys are neutral. Someone can sit there and rant all they want. It's like, okay, you've got one vote. What I'm looking for is just the broader sort of thing. And obviously you want to have people, like you want to make people like, really make people happy. But the point is like, you really can't make everyone on Earth happy. So trying to figure out like what's kind of like, are there general trends and stuff like that. That's not really like about designing reverb. That's more just a businessy thing. This is kind of something is like, I actually end up talking to a few people. Like I'd love to know why people did this stuff. Like what was it like to make reverbs back in 1975 or whatever. And definitely had some people about it, but it's like, I don't know, I'd still love to hear from some of these people, because some of them are like starting to pass on or getting close to it. So it'd be like nice to, we're losing some of that sort of history. Now the history is there in the, like the algorithms themselves are in the ROMs, and you can kind of figure it out. But I just wonder is like why people made the choices they did. Like I can sit there and just sort of, it's like, I explain, it's like I like computer music. I like big, complicated sounds as a way of cheating. But other people have their own reasons for doing things, like why they got interested in it. So it'd be nice to hear from other people how they did that.